Avogadro's law and Avogadro's constant. Relationship between mole and Avogadro number. This portion you studied in 10th standard. I'm just giving you a revision of that portion. Avogadro's law. Equal volumes of all gases contain equal number of molecules under similar conditions of temperature and pressure. Any gas at STP, that is 0 degree centigrade or 273 Kelvin, 1 atmosphere contains 6.022 into 10 to the power of 23 molecules. Avogadro number or Avogadro's constant is this number. Mole. A mole is the amount of any substance which contains as many elementary entities, atoms, molecules, or ions, as there are atoms in exactly how many particles are present. For example, carbon considering as an standard element, we consider that 12 grams of carbon contains 6.022 into 10 to the power of 23 atoms. When we talk of mole, we must mention the entity that it represents. We must mention whether the given quantity is 1 mole of molecule, 1 mole of ions, or 1 mole of atoms, etc. The concept of mole can even be extended to fundamental particles like electrons, protons, etc. 1 mole of electron means 6.022 into 10 to the power of 23 electrons. Thus, mole is simply a unit for expressing the number of atoms, molecules, ions, electrons, etc. Thus, we may conclude that 1 mole in general is equal to 6.022 into 10 to the power of 23 particles. These particles, what it is to be mentioned. For example, 1 mole of atoms is equal to 6.022 into 10 to the power of 23 atoms. 1 mole of molecules means 6.022 into 10 to the power of 23 molecules. And 1 mole of ions means 6.022 into 10 to the power of 23 ions. 1 mole of electrons means 6.022 into 10 to the power of 23 electrons. The number 6.022 into 10 to the power of 23, that is called Avogadro number, and is supposed to be a very significant number in chemistry. Avogadro number is normally represented by capital letter N. It is also represented by capital letter N and with a subscript A. The following is the Avogadro number expression. Avogadro number N can be expressed as the number of atoms present in 1 gram atom of any substance, which is also equal to the number of molecules present in 1 gram molecule of any atoms, any substance. Third, it is also equal to the number of ions present in 1 gram ion of any substance. For example, oxygen atomic mass is 16. We can say that 16 grams of oxygen contain 6.022 into 10 to the power of 23 atoms. Consider O2, 2 atoms of oxygen. 16 plus 16, that is 32. That is, molecular mass is 32 grams. Therefore, 32 grams of oxygen contains 6.022 into 10 to the power of 23 molecules of oxygen. This is the explanation regarding the Avogadro number and mole.